Dear students, today I'll be starting with the activated sludge process. Okay, it is about the activated sludge process. We also call it ASP. Last class I have done about the treatment filter. We know that in the water treatment plant, in the wastewater treatment plant, the secondary treatment after the primary, it specially comprises of the removal of the nutrients or the substrate, which we call it the BOD or the COD. For that, we employed the biological process. In one of the biological process is, I explained already, the aerobic, anaerobic. In the aerobic, again, it is the attached growth system, suspended growth system. In the attached growth system, already I have done the tricky filter. Today, it is going to be done on suspended growth system. Suspended growth. Over here, in this biological process, the microbes are going to be in the suspended forms, which we call it the sludge. This suspension, they are going to eat the nutrients, that is the substrate, the BOD, and that way we are going to remove the BOD. And the sludge that's going to grow in suspension will be settled down as a sludge, and then we are going to wasted it, and hence water will be cleared from the BOD. Okay. Now suspension growth or suspended growth, another example of what I'll give is, say for fish, example. The fish, in order to sleep, they don't have to lie on the ground and sleep. When the fish needs to reproduce or eat, they don't have to lie down and reproduce, or they don't have to lie down and eat the food. They can swim, they remain in suspension, they can eat, they can lay the eggs, then they can do all the activities. So, even though fish has got the microbes, I'm just giving an example. What do you mean by suspension? Okay. Similar to microbes, they swim in the water, they remain in suspension, and they don't need any media. Unlike, say, example like mosses, the phytoplanktons. So when you have a surface or the bricks in the water or the wastewater, the algae grows on the surface of the bricks or media, right? So those are attached growth system. So now it's going to be suspended growth, biological process for the removal of the BOD, COD, the substrate, and it is called activated sludge process. As per the BTech syllabus, the design of the ASP is quite tough, even though it is MTech. Today, however, from a basic point of view, like your Public Service Commission or your engineering surveys, we are going to do your activated sludge process design. Okay. So now let me begin with the terminology so that at least you can answer the basic fundamentals during your exam time. Okay. You see these things. We know that the wastewater is coming from after the primary treatment. This is after the primary. Okay? Let's assume that this is your activated sludge process. Okay. Does it look quite symmetric? No. It doesn't look symmetric. Okay. Now, please look over here. First, some of the parameters of main importance are, number one, please check it, the Q. What is Q? Already we know Q is meter cube per day or liter per time. The Q is coming with a particular discharge. Where it enters, number two, it comes with BOD, or we call it substrate. So it is denoted with S naught. O is why, because it is 0, S0, it is the initial concentration of the BOD that is coming to be treated. Okay, fine. So the wastewater is coming along with Q and along with S naught. Now another one is, when it enters, after it enters, this is called the aeration box. I will say this is the aeration box. Aeration means some aeration is going to be there. It's going to steer. So by steering it, it's going to make the water in the turbulence form. Therefore, it is going to enhance the surface area, enhance atmospheric oxygen. The dissolved oxygen will be coming over here. Okay, by aerating it. So over here, the dissolved oxygen is there and BOD coming is there. So aerobic microbes can start eating up the BOD and hence it can reduce the BOD, thereby producing more and more sludge. Now you see over here, the moment it goes SO over here, this here, the concentration is S, number 1, S naught is over here, okay. Then this is the BOD is done inside a reactor, we call it volume. These are some of the parameters, just have a look. This is the volume, and after this BOD is eaten by the microbes, initially the microbes will be very, very less. The microbes is going to increase and we call it X. So what is X? X is, we call it biomass. It has different terminology. Either it can be a biomass or it can be microbes. What microbes? It may be aerobic microbes. Okay, so X as the biomass. Initially, so you can ask me, so what about the incoming biomass? Was there any microbes? Maybe there. So we can add the incoming as X naught. But I'm telling you, this X naught is very, 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 very less. Because there were no much biomass, because the proper aeration was not there before the treatment. So biomass was very, very less. However, the BOD it was very, very high. This is going to be removed. Okay. So we have 3 parameters. Number 1 is the initial BOD that is designed inside ASP reactor, and now finally the biomass is increased. Okay, fine, clear. Now, after that, what happened is the water is treated, all the biomass are increasing, the population is increasing, the S will be reduced, and the treated water, it goes out here. In the treated water, all the biomass will be settled down, X will be settled down, correct? So whatever is coming out, some of them escape out, it is called XE. This is called biomass in effluent. We don't expect the biomass to be out. Biomass, we are going to make it settle down over here. The biomass will be settled down over here. Okay. However, since everything is not perfectly controlled, some of the X may escape out, but the concentration may be very, very, very less. Say for example, you try to have a lot of suspended solids, it is settling down, some of them escape out. So when some escape out, the concentration may be very, very less and it escape. But all the concentration are concentrating over here. Okay? So escape out is very, very, very less. Excuse me. A lot of disturbance is there. So, let me check whether still the video is there or sometimes some issue is also there. Thankfully it's there. So the Xe is going to decrease very much because it's diluted. And what about the S naught? The BOD coming out is going to be very, very less. So it is the effluent. The BOD effluent. Some of them, it's not that all the BOD can be completely removed. Some of them will escape out. So this is called BOD effluent. And it's very, very, very less. How much? As per the permissible limit, it is 30 milligram per liter. Correct? So the incoming BOD may be around say 250, 300 milligram per liter. In domestic wastewater, the effluent will be around 30 milligram per liter as per the permissible limit. And we have to design for that. So now, this is the concept. So, when all the biomass is going to be concentrated over here, the biomass will be completely compacted. These microbes, they will be compacted over here. Okay, and this biomass day by day, it is going to increase. Therefore, we have to waste the sludge. But before that, let me say, if Q is coming inside, the coming out will be Q again. Okay, I'll rectify this one. This is Q, say for example, not exactly Q. So all the solids, these are sludge. Why we call it sludge? It is same as biomass. The thing is, this is a biologically active mass inside. So we call it biomass. It is microbes. However, if you are not going to use it, you are going to be wasting away. We call it sludge. So this sludge has to be removed, otherwise they will increase and they will affect the volume, correct? So what happened is, this coming out is been completely wasting away, and this is called QW. QW is wasted sludge discharge. Yes, I told you before already, the sludge itself is nothing. It is around 2 to 4% of solids, and remaining are all water plus water, correct? So some water will be coming out and it has to be wasted away. So this is QW. But what about the concentration? The concentration will be something, I'm coming to the point. But now, another problem is, when the fresh wastewater is coming inside, listen very carefully, when the fresh wastewater is coming inside, the new biomass is growing up, it's acclimatized, it's growing up, and then it treats. But if you try to remove whatever biomass, whatever the sludge, if you remove everything, to make a new population from the incoming wastewater, it takes time again. Say for example, if you want to train some armies, you train one batch, throw it out, another batch, throw it out. It's difficult. The first batch, some of them you remove it away, some of them you left. Whoever coming new will be acclimatized to the system with the help of the old armies, old soldiers, correct? So, in order to reproduce the new biomass again, some of the sludge or biomass is again recycled back. So, we recycle it, this is called recycling. Some of them we recycle it. Okay, so this is nothing. This concentration of the sludge itself, we call it X is the biomass, but R is the recycle. Okay, this is recycled biomass. Okay. Now you please look over here. Since sum of this X are, what is this? This is biomass. But what biomass? This is called active biomass. Active means fresh, light, strength, which can have again mingle with the new incoming solid waste, liquid waste, and can again start a new reactor. So this, because of this active biomass, the whole system is called activated. Instead of biomass, we call it sludge, same activated sludge process. And hence the name ASP. Is that clear? And hence the name is called activated sludge process. Because the active sludge is again recycled and reused again. Not completely, some of them. Is that clear? So it is called activated sludge process. This activated sludge, they are already acclimatized, well acquainted with the system. So if they are recycled, the incoming BOD can be eaten by these microbes very fast and can develop the system very quickly. Okay, so the whole system is called activated sludge process. Now you see over here, what about this one? So this one, I will say this Q is going to be split into here. So I'll say this is QR. Okay, this is QR. So this side, this may be Q. I will say QWW or Q wasted, Q wasted, QW. This is Q1, this is QW2. This is completely wasted. Now, this QW1, this is nothing. QW is equal to QW2 plus QR. Am I correct? Because this is split into two. But what about the concentration of the biomass? The concentration of the biomass here will be same. This is also XR and this is also XR. The reason is, you see over here, I have a cup of a coffee. This cup of coffee, a mug of coffee. Mug of coffee is 1 liter. So 400 ml I give it to my right side, 600 ml I give it to my right side. Okay, so this side is 400 XQR, 600 I wasted it. But even though it is split into 40% and 60%, the concentration of the sugar over there will not change. Am I correct? Even though you split the coffee jar into two parts, do you think one part of the coffee will be more sweet or more sweeter than the another? No, because the sugar concentration is same in both the sides. So similarly, the concentration of the biomass XR, XR, XR all are same. Another example, I'm saying I have a cup of coffee. I give some to my one friend, one to another one. Though they may have different volume of the coffee, the sugar concentration in what I'm having and what I'm giving to both will be same. Correct? So XR, XR, XR. This is a mass balance of the complete activated sludge process. And therefore, since Q is coming and QR is going, sometimes we put this one as QW. Because Q is coming, QW, it is wasting it away. So Q minus QW is the effluent coming out. That means even though I may be saying 10 liters is coming inside, 1 liter is wasted away. So this will be 10 minus 1, this may be 9 liters effluent. Is the concept clear? Let me check the video again. Fine. Okay. So this is the complete mass balance of what is activated sludge process. Now, some of the very, very important parameter is this volume is one of the most important parameters, because based on the volume, the amount of the sludge, amount of the space will be there. the X, the QR, everything. Okay. So right now, let me define some of the important parameters of activated sludge process along with the numerators. Okay. So in case if you want to have a look, you check it again, pause the video and have a look. Now let me rub from my side. Okay. Now, some of the important are, firstly, some factors, some important factors. Okay, see. If our main option or main objective is to treat the maximum BOD as much as possible. So, if you want to treat more things, the operational parameters, I told you, number one is HRT, the hydro retention time. It is defined by, what is HRT? HRT is QT, it's called volume. So, volume by Q. This is number one. So, how you design a volume, how much HRT is important for the coming Q, that we will calculate. I'll come to the point. Number two is, another one is something called F by M. This is also called food to mass ratio. Now, what is food? Food is nothing, it is the BOD, correct? What is the mass? Mass is the biomass. The biomass, the BOD is the food of the microbes. Correct? And the mass means is the biomass. Now say for example, if a lot of food is coming, a lot of BOD is coming, if your microbes is very, very little, will they be able to eat? No. Food is too much, only few people, the food may escape out because they are going to stay only for a particular HRT. So, how much food is coming for how much mass of the microbes, that is also very important. So, this equation can be said as, what is the food available over there? Food available is Q into S naught. Correct? Because this is meter cube per day and S naught is milligram per liter. Milligram per liter. So you can check over here, this meter cube and liter are water volume. It can be cancelled, so it is meter gram per day divided by how much biomass is there. Biomass inside the reactor is X into the volume. So for this one is biomass means this much milligram or gram per liter of, for every liter this much milligram or gram of microbes are there, then the solids into the volume. Volume means meter cube. So these two can also be cancelled. Am I correct? So what is left is, rather I'll say milligram per day. Am I correct? Per milligram. So instead of milligram, we said as kg. This is what? Kg of BOD. Excuse me. Per sludge, actually it's in terms of grams. Grams of biomass per day. So this is the food to microbes ratio. Is that okay? Fine. Another important parameter is the sludge. You may ask me, sir, for the sludge, you are going to remove the sludge from the bottom. For how long you are going to keep the sludge over there? Say, if you don't remove the sludge, what will happen is the volume of the sludge will keep on increasing, and the effective volume of the reactor will decrease. Therefore, you have to remove the sludge. But again, if you remove everything, is it good? No. If you remove all the sludge, then who is going to eat the BOD? So some has to be maintained. So my point is, for how long time the sludge has to be remain in the water? That is called sludge retention time. So that we know after how many hours, how many days the sludge has to be removed. This is also called SRT. Sometimes we call it theta C. Okay. So this definition is given by sludge in the reactor. Sludge in the reactor divided by sludge living in the reactor per day. So sludge in the reactor, this is also sludge living in the reactor. All our sludge, these 2 units will be cancelled per day. So it will be 1 by day. So it will be in terms of day. The unit is day. So how many days the sludge will stay? That is the SRT. Okay. The formula will be given by, let me rub the first part. You can pause the video. This first part I am removing it. This, okay. So you look up second part also, then we removed it. So sludge in the reactor, you know, sludge in the reactor is X into V is a sludge in the reactor, correct? A sludge living in the reactor per day. So what is a sludge living in the reactor? That is QW. That is the wasted discharge into, as you remember, look over here again. This is number 1. We are wasting the sludge. It's leaving the sludge. Sorry, I'll say this is leaving the sludge, and some of the sludge also leave from here. So this is also leaving. So the sludge leave the reactor in 2 ways. One is from the bottom part, and another one is in the effluent, correct? So this part is QW and it was XR, correct? But what about the leaving? Leaving is Q minus QW. What is the reaction? This is XE, correct? So QW into XR plus Q minus QW into XE. So this is, X is milligram per liter into volume is liter. So liter is cancelled, divided by QW into XR. Q is meter cube per day into XR is milligram per liter. So this meter cube and this was cancelled. Liter and liter is cancelled. So milligram and milligram will again be cancelled. So this day is left. So it is becoming day. Is it okay? Is it fine? So this is SRT. Now, is it fine? You can have a pause the video and take a look. Now, another example is, in case if the biomass in effluent is very, very insignificant, because almost the biomass escaped over here, this XE is very small. We try to remove completely at the bottom. In case if this is very small, then this part can be made almost as zero, neglected, and hence it become XB divided by QW into XR. So this can be also one of the SRT equation. Considering that this is zero, okay? Fine. Now I'm going to solve the one numericals. Let me check the video. Fine, okay? Okay. Now we can have one numericals for these questions. The question is, ASP has number one. Okay, so Q is equal to 35,000 meter cube per day. The flow rate is 35,000. It is already designed with the volume of 10,900 meter cube, and the BOD in is equal to 250 milligram per liter, and BOD effluent that is coming out is permissible is 30, so it is coming as 20 milligram per liter. And then I'll come, don't worry, MLSS, don't worry for this. MLSS is 2,500 milligram per liter. Then effluent suspended solids is equal to 30 milligram per liter. Waste sludge suspended solids. Waste sludge suspended, I'll write. Suspended solids is equal to 9,700 milligram per liter. After doing the numericals, most of the concept will be clear. Quantity of sludge wasted is called 220 meter cube per day. Okay. So let it be. Now see over here. From this value, let me draw a rough picture over here. Let's say this is the reactor. The main important is you should know how to interpret this given data into the pictures. Okay, so Q is 3,500. So this is Q is equal to 3,500 meter cube per day. The incoming BOD is not. So this is done. BOD incoming is 250 milligram per liter. Okay. Then BOD effluent is 20 milligram per liter. This outgoing BOD means SE is 20 milligram per liter. This is done. Volume is 10,900. The volume is 10,900 meter cube. And then MLSS. MLSS stands for mixed liquor suspended solids. that is the X, mixed liquor suspended solids, means the suspended solid inside, we call it MLSS, or it is X, is equal to how much? 2500 milligram per liter. And then effluent suspended solids. Effluent suspended solids means the total suspended solids effluent is equal to 30 milligram per liter. This is done. Wasted sludge suspended solids. Here, the solids that is wasted over here, maybe recycled or maybe wasted, whatever. This XR is equal to 9,700 milligram per liter. And the quantity of the sludge wasted, and this QW is equal to 220 meter cube per day. This is the picture. The whole question is picturized as this. Is that clear? Let me see the video. It's still recording. Yeah, well, going on good. Now, the first is, let us find what is the HRT. HRT is volume by Q. So volume is how much? 10,900 meter cube divided by Q. What is Q? 3,500 meter cube per day. So they will go, HRT will be in terms of days, is equal to, can I say like this? It is, if this is cut, 109 divided by 35 into 24 hours. Okay, 109 divided by 35. Finding the calculator apps on a mobile is another bit of thing for me. 109 divided by 5 into. Is the question correct? 3,500. 35,000. Oh, 1 0 is missing. That's why. 350. 109 divided by 350. 24. This is 7.47 hours. So the HRT is 7.47 hours. What is the next parameter we are supposed to find? The foot to mass ratio. Is it clear? Fine. So HRT is 7.4 hours. Okay. Now I think all these values can remove since I put that in the pictorial form. Number 2, what is the foot to mass ratio? Foot to mass ratio. Foot is, I told you, the BOD. How much BOD is there inside? Okay, that is Q into S naught. Mass, how much mass is there? That is X into V. So Q is 35,000 meter cube per day. BOD is 250 milligram per liter divided by X. X is 2,500 milligram per liter. What is the volume? 10,900 meter cube. Okay. So from here, in another way, this milligram per liter and milligram per liter can be cancelled. Meter cube and meter cube can be cancelled. So whatever you obtain, it will be, oh no, don't cancel it, don't cancel it. Don't cancel it, let it be. Because we want to find in terms of kg per day, right? Let it be, let it be. So let's see the value. 35,000 into 250. 35,000 into 250 divided by so we got 0.321. The important is what is the unit? What I want is I want the food in terms of kg of BOD. Okay, so this meter cube and meter, anyway. So anyway, you see in different way. This milligram per liter can be cancelled. Meter cube is cancelled. So whatever left is only D. So you can say that this is 0.31 kg of BOD per kg per day biomass. Is it okay? So the answer is food to mass ratio is, the unit should be same over here since everything is cancelled. So it is 0.321 kg of BOD is eaten by 1 kg of biomass per unit day. This is the food to mass ratio over here. Is that okay? The next one is so the next one can be, what will be the next one? As we have done it, next one will be percentage of reactor. It's very simple. That is incoming BOD minus outgoing BOD divided by incoming BOD into 100%. So 250 milligram per liter of BOD is coming and outgoing is 20 is coming out of 250 into 100 percentage. So the effectivity is 230 divided by 250. 230 divided by 250. So it is 92% efficiency. Okay. Is that okay? Now look over here. And the last one is SRT. Sludge retention time or θC. So it is a sludge in the reactor. Sludge in the reactor is what? How much X is there into volume is the sludge in the reactor. Sludge leaving the reactor. So this is a sludge that is leaving the reactor, and another one is this is a sludge that is leaving the reactor. Solids means it is a sludge. So another one is this is QW into XR plus Q minus QW into XE. Okay, what is X? The biomass over here is, the sludge in the reactor is 2500 milligram per liter into what's the volume? 10,900 meter cube divided by sludge leaving the reactor. QW, what is QW? 220 meter cube per day into XR is 9,700 milligram per liter plus Q minus QW. The Q is 3,500 meter cube of 35,000, I think. Is it 35,000, right? The question was 35,000. Yeah. So 35,000 is coming and 220 is gone, means whatever here will be 35,000 minus 220 meter cube per day. Correct? So this is going to be 35,000 minus 220 into how much concentration? 30 milligram per liter. Okay, so this is 2500 into 10,900. It's very huge. Divided by 220 into 9700 plus. Now it's very, very complex because mine is not a proper calculator. What I'll do is 35000 minus 220 is equal to 3478 into 30 is equal to. So this part is 10,400. Upper part is 2500 into 10,900. This is 2725000. This is 9700 into 220. 2134 plus 1043 400 equal to divided by 2725000 in inverse. So this is 8.57 days. Now let me check the things unit. Milligram per liter. This milligram per liter will be cancelled. Meter will be cancelled. So 8.57 days is coming. Okay. So this is the total final pressure. That means the sludge should be there in the reactor for around 8.57 days. So that is all about activated sludge process. Okay, last part. Is it okay? The last part is so please have a look for a few seconds. I'll give a few seconds to digest rather than muting your things. Now, another thing is, we discussed, sir, what should be the concentration of the sludge that we want to recycle? If you want to recycle the sludge, that is, what should be the value of XR? This comes a very, very important question. How much should we concentrate? Because the moment it's going to come down, we are going to make it stay for around 9.57 days, but what should be the concentration? Okay. To see these things, what we do is QR, how much the sludge should be recycled, should be equal to XT divided by XR minus XT. See over here. This is the amount of the sludge that has to be recycled, the flow rate, and this is the actual flow rate. The ratio between the amount of sludge to be recycled to this one, there is a recycled ratio, should be in the ratio of the sludge in the reactor and this is the condensed sludge, the difference between the settled sludge and the MLSS in the reactor. XT is nothing. This is the MLSS, or we call it X, correct? So this ratio is very important. How we define this QR, again I'm coming to the point, the ratio between the sludge that is to be recycled, the flow rate, to the original flow rate of the reactor should be in the ratio of the sludge in the reactor MLSS divided by the difference of sludge settling in the bottom and the sludge in the reactor. Okay, now the next question is QR and Q is there. Now, what happened is there is a particular thing called sludge volume index. We also call it SVI. The sludge volume index, this is going to explain the physical state of the sludge. Means how much the sludge contains. If the sludge is very, very dilute, it may be a problem. If it is too condensed, it may not flow. So, how we define this sludge volume index is the volume occupied in milliliters by 1 gram of sludge in 30 minutes. Okay, so let me rub this part. What we do is, we've got a device for sludge volume index. Okay, so we'll put the sludge over here. The sludge is black in color. We'll put a sludge over here. And what happens is, you keep for 30 minutes. Then, at the bottom part in 30 minutes, some solids will start to settle down. This way starts to settle down in 30 minutes. Okay, fine. So the sludge that is settling down in 30 minutes by 1 gram. But you may ask, so how do we know this is 1 gram? I'm going to come to the question. This ml of volume divided by dry solids in gram. This is called the sludge volume index. So this is going to give the physical characteristics of a sludge. If the sludge is very, very light, even in 30 minutes, they will not settle down properly, correct, by 1 gram. So the another importance of this is, this XR value, this QR, we know how much we want to recycle, or this is what we have to find out. Q we know, XT we have estimated, XR. What we do is, this XR is related as 10 to the power 6 divided by sludge volume index. We always try to say, you must concentrate the recycled sludge in such a way that 10 to the power 6 divided by the sludge volume index, that value you should obtain as XR. So you have to concentrate the sludge until and unless you didn't get a value of 10 to the power 6 by SBI. And what is SBI? You have done the experiment. Am I correct? So remember, this is a design parameter for the recycling. Next is, what is XR? XR is 10 to the power 6 by SBI. Now, then you may ask, sir, let's do one example of SBI. A question. This question was also there in Public Service Commission, Manipur Public Service Commission in the year 2019. Okay, so let me ask you one question, that is, one liter of sludge you just collect the sludge when allowed to settle for 30 minutes gives a sludge volume 27 centimeter cube. Fine. The dry weight of sludge is 3 grams. Then what is sludge volume index? Is it okay? So simply you pick up some sample, the whole sample. This one is 1 liter, and this you settle for 30 minutes, and after that you realize that this part is 27 centimeter cube. Okay, now after this part is again dried and you weigh, it gives 3 gram. The dry solid, if you dry it in an oven for 105 degrees centigrade, I explained you in the practical part, this will give 3 grams. But the volume occupied is 27 centimeter cube when kept for 30 minutes by complete 1 liter of the sludge. Then what is the sludge volume index? It's very simple. I said, what is that? The volume occupied, that is SBI, the volume occupied is 27 centimeter cube divided by the volume, the weight of the solids, that is 3 gram per gram in 30 minutes. This is standard. So this is 1 centimeter cube is called 1 ml. This is 9 ml per gram. So this is the SBI of the sample. Is it okay, clear? So here I like to add. Now already ASP is explained and how much the sludge recycle has to be is explained, and how to correlate between how much the flow rate, the concentration of the sludge, recycle XR value is also explained, and it's also correlated with the SBI, the practical strength, physical strength of the sludge, how to estimate. And this is very funny that this question itself was asked for 20 marks in Manipur Public Service Commission in the year 2019 or 18, I think, in SO exams. Okay, so here I'm going to wind up regarding the activated sludge process. Fine. Thank you.